Welcome back. So now we're going to review solving all the different types of quadratic equations: standard form, vertex form, intercept form. I think I have 6 or 7 here. I don't know if this is going to be one podcast, but let's find out. All right. So step number 1, we have first of all our equation, and this one is standard form. So I will write the forms just to help you be able to learn their formats, all the 3 different formats. So standard form, so when we're talking standard form, right, we need to solve for the vertex and axis of symmetry using the handy-dandy formula, x equals negative b divided by 2a. If this was intercept form, we average the x coordinates. We do something different because our equation is different. And if it's vertex form, we don't do anything, well, other than identify the vertex, because the vertex form gives you the vertex, right? So just some slight differences between our different formats, right? So for this format, since it is in standard form, we're going to use this to find our axis of symmetry and vertex. In any of the formats, all we have to do is look at A to determine whether our graph opens upwards or downwards, right? So A, remember, is the coefficient in front of x squared when it's in standard form. If it's not in standard form, then it's the coefficient in front of some parentheses, either a something squared or the 2 factors. Right? So here A is 6. So since A is greater than 0, the graph is concave up. It's our first concave up graph in this whole lesson, besides the one we started with. All right, so we want to find the axis of symmetry. Our axis of symmetry, we identify A and B, right, and that's going to find the axis of symmetry and the vertex when it's in standard form. So our A, we know, is 6. B is negative 4. So our axis of symmetry is going to be x equals negative 4 divided by 2 times 6. So that's going to be a positive 4, and 2 times 6 is 12. So our axis of symmetry is 1/3. So in a previous lesson, we changed the scale because our numbers were too big. In this lesson, we might change the scale because our numbers are kind of teeny. But let's find out the y-coordinate of our vertex, and it's in standard form. Let's just plug it in. And so here we have a 1/3. Actually, you know what? Since it is a 1/3, and we didn't do the k formula in the last lesson, let's use our k formula. All right, so k is equal to negative, all negative, b squared minus 4ac divided by 4a. So it looks a lot like quadratic formula, but no square root, nothing added in, just a negative, right? And it's 4a, because our x-intercept is going to be halfway, our vertex is going to be halfway between our x-intercepts. All right, so now we're just going to plug in the a and the b, and our c is 0. So if there's no constant, it's 0. So k is equal to negative, and then we have negative 4 squared, which we could write neater. So I want to square the negative, that's why that's in parentheses. And I have another parentheses because the whole thing is the opposite. And then we have minus 4 times 6 times 0. All divided by 4 times 6. So that's going to give us, so we're going to have negative, and negative 4 squared is 16. And now 4 times 6 times 0, that's just 0. That's all gone. And then we're divided by 24. So k here is just negative 16 divided by 24. And those are both divisible by 8. So that's k is negative 2/3. So our vertex is the point 1/3, negative 2/3. And I really think we're going to make our scale go up by something other than 1. How about make our scale go up by a third? Each line will be a third. That'll work out great. So I'm really glad I used the K formula because I think that was a lot easier, especially since half the equation was 0. The y-intercept, it's in standard form. Just identify your constant term. What if there is no constant term? Then it's 0. And your y-intercept is 0, 0. And if you're ever not sure, you can always plug in 0, right? And so you'd have f of 0 would be 6 times 0 squared. Actually, let's put it over here. It's all smooshing in with my k. So we'd have f of 0 would be 6 times 0 squared minus 4 times 0. Well, that's clearly 0, just in case you're not sure. All right, so we've got half of the things we need, actually more than half. All we need now is the x-intercepts. And this is super easy to solve. So super easy. So you find your x-intercepts. You're going to set the function equal to 0 and factor. When c is 0, all you have to do is factor out the greatest common factor. It'll always be factorable. We always have something that's going to divide into each one of those, at least an x, and in this case, a 2x. So we can factor out a 2x. 6x squared divided by 2x is 3x. Negative 4x divided by 2x is going to be a negative 2. And we're factored. That's all there is to it. And then you just set each factor equal to 0. So 2x is equal to 0. Well, you divide 0 by 2 and it's still 0. So one of our x-intercepts is 0, 0. And that makes perfect sense because that was our y-intercept as well. So if you're 0 for the y, you've got to be 0 for the x. And then we have 3x minus 2 equals 0. We'll add 2 to both sides. So 3x is equal to 2. And finally, divide both sides by 3. Our x is 2/3. Crammed in there. I'm going to move this up just a little bit so I can write that as a point. That would be the point 2/3, 0. And having our scale go up by a third is sounding really, really good. Now all we have to do is graph. So we have all the information. Our x-intercepts were 0, 0, 2/3, 0. So every time you graph, you're going to find your key values. 0, 0, 2/3, 0 for the quadratics. And that would be your x-intercepts, which we have. Your y-intercept, which in this case is the same as one of your x-intercepts. Your vertex, right, which is 1/3, negative 2/3. And then you're going to make sure you remember your direction. Right? So for graphing our quadratics right now, that's all we're going to need to do. All right, so our axis of symmetry was x equals, now that I said that, it was a positive 1/3, not a negative 1/3. Yes. And our vertex was the point 1/3, negative 2/3. The y-intercept was 0, 0. The x-intercept was also 0, 0. And negative, it was, no, positive, excuse me, positive 2/3, 0. All right, so now we're going to make each of these go up by a third. But rather than trying to cram a third in there around one little box, so if each box is a third, it means 3 boxes equals 1. Let me move this line out of the way. All right, so that's going to be 1, and this would therefore be negative 1, and the same on the y's. That will make things much, much easier for us because some of our numbers are kind of tiny, rather than having a graph, that fits into 2 squares. All right, so feel free to change your scale. Nobody says each box has to equal 1. Just be consistent. So now let's put in our axis of symmetry. So now it's easy. I'm not trying to figure out a third of a box, right? Because each box is a third. Right, I'm actually going to write that down here. X equals 1/3. I should have done that actually on the other ones. and I kind of forgot. I forgot to write in the axis of symmetry. We had it written in on the side there, but I just didn't write it in on the graph. So maybe you could do that. Go back and do that for me, and I'll go back and do that on my notes here before I post them. All right, so we have our axis of symmetry. Let's graph our vertex. Right, so that's going to be 1/3, negative 2/3. So that's going to be, since each box is a third, we'll just count 2 boxes. We have 1 x-intercept there, and let's write that down. So this is 1/3, negative 2/3. This is 0, 0. And then our other one is at 2/3, which would be, sorry, I'm looking at my axis of symmetry, thinking that's the y-axis. Right here is 2/3, 0. That red just stands out. And we have, that's all our points that we have. So remember in an earlier podcast they said, if your whole graph is all teeny tiny and you're trying to graph, it's helpful to have one more point. And if you look here, our graph, we got 3 points because one of our x-intercepts and our y-intercept is exactly the same, which means not only do we not have a different point for the y-intercept, we can't use symmetry to get any more points. Right? So let's plug in 1. That would be a great point. And then we could get 2 points, right? 1 on the right and 1 on the left. Then we could use symmetry because we'd have something that wasn't and a point we already knew. All right, so we have f of 1 equals 6 times 1 squared minus 4 times 1. And sometimes that makes it a lot easier to graph, especially when you only have 3 points. So this would be 6 minus 4, and that's 2. All right, so now we have a bonus point. So this is I call this our extra point. Our bonus is going to be the one we get using symmetry. So our extra point here is 1, 2. So 1, and then we're going to have to count up, so everything's a third. So 1/3, 2/3, 1, and then 1 1/3, 1 2/3, that would be 2. So we count 6 boxes. If you have one that is 2 spaces to the right from the axis of symmetry, there has to be 1, 2 to the left, right? Because it's symmetric. Now, isn't that much easier to graph than those tiny 3 little points? So I do this anytime my values are all clustered together, or I don't have all of my points because maybe my x and y are the same, or my x and vertex are the same. Then I get a few extra points that way. All right, and domain and range, and then we're done. And of course, we know the domain is all real numbers. The range, this time, our parabola is reaching to the sky. So the high value is going to be infinity. The low value is the y-coordinate on the vertex. So negative 2/3 is the smallest y value to infinity. And we're done. 1 down, 6 more to go. Let's graph, or 5 more, I'm not sure, I don't remember. It was 6 or 7. Let's graph the next one, though. We'll go for a little bit longer. It's only been 13 minutes. All right, so we're going to graph the function f of x equals 1/2 times x plus 4 times x plus 8. Let's find the axis of symmetry. And before we do that, why don't we just go ahead and find our x-intercepts? Because that's really what P and Q are. Let's just find those, all right? And I think that might make it easier for some people. All right, so if we set, now notice, remember before when we divided 0 by negative 1, it was still 0. And if you multiply 0 by 2, it's still going to be 0. All right, so I'll write it over here. However, it's not going to change 0. So essentially, what you're going to have is just your factors, the product of your factors set equal to 0. So you could, instead of multiplying both sides by 2, which isn't going to change the 0 at all, you could just set your factors equal to 0. Right? So you don't have to actually isolate the factors, because when you're done, all you're going to have is your factors, the product of your factors equals 0, which means that if your factors equal 0, it means you have to set each factor equal to 0. Because we know if we multiply two things and we get 0 as the product, there had to be a 0 in it. All right, so we have x plus 4 equals 0. We would subtract 4 from both sides. So x is negative 4. And if we have x plus 8 equals 0, we would subtract 8 from both sides, so x would equal negative 8. So by the way, this has nothing to do with the y-intercept. I just didn't feel like extending the page. And I used this area. But all of that is just our x-intercepts. And had I just written a little bit smaller, I would have had space. I could have had space. All right, but there it all is. And you can always, if you have more space on your paper, well, you don't have to write it up there. I just was starting to run out of space, and I didn't know if I wanted to extend the board. So I just used that space. Now that we know our x-intercepts, we can find our axis of symmetry and our vertex. Right? Before we do that, let's just identify our direction of our graph. There's our A. Our A is 1/2. That's a positive number. So since A is greater than 0, our graph is concave up. Yeah, let me squeeze that in there. Whoops. If I put it down here, so I don't have to put up on its own line, graph is concave up. There. Keep it the same color. All right, so we've got concave up. We have our x-intercepts. For intercept form, that P and the Q, those are just your x-intercepts. All right, so the axis of symmetry is just going to be equal to the average of -4 and -8, because the vertex has to be halfway in between. So x is going to be -12 divided by 2, which is -6. So for our vertex, and our vertex we use HK, so where it has H equals that axis of symmetry, the value that it goes through on the x-axis, because our vertex is on the axis of symmetry, is also the x-coordinate of our vertex. To find the y, you'll just plug in to your equation. So we have f of -6 equals 1/2. Come on. -6 plus 4 times -6 plus 8. So that's going to be 1/2 times -2 times +2. And so -2 times 2 is -4. Half of -4 is -2. So your vertex is -6, -2. The last thing we need is the y-intercept. And to find the y-intercept, we're just going to plug in 0 for x. So you can see I didn't need very much room for the y-intercept. F of 0 is 1/2 times 0 plus 4 times 0 plus 8. Right? So other than standard form, which you can figure out just by looking at the equation, when you're finding your y-intercept, you'll always just plug in 0 for x. That's true no matter what the graph is too. So we have 1/2, so that's just going to be 4 times 8. So half of 4 is 2. 2 times 8 is 16. So that's our y-intercept. All right, so our y-intercept is the point 0, 16. Our vertex is the point -6, -2. And our x-intercepts, I'll just put them over here. Our x-intercepts are negative 4, 0, and negative 8, 0. We solved them over there, but I started to run out of space. Let's take all these values, put it on the next page, and graph. All right, so our axis of symmetry was x equals negative 6. The vertex was negative 6, 12. Y-intercept was 0, 16. And the x-intercepts are negative 4, 0, and negative 8, 0. Let's just graph. All right, let's move our axis of symmetry to the right location. So let's move it to negative 6. And I'm not changing the scale here, so I don't need to. 1, 2, 3, 4, 5, 6. So you can draw your axis of symmetry there. Let's write it in, the equation for the axis of symmetry. Now all we gotta do is graph our points. So we have negative 4, 0. Sorry, I sneezed there. Let's try not to. Negative 8, 0. Those are our x-intercepts. And then the vertex is, it's not upside down. So was it supposed to be negative 6, negative 12? Did I just write down the wrong value? So that's why, oh, it's negative 6, negative 2. So obviously I just didn't remember the right value. So that's a nice thing. So the copying error there, we know that that can't be right because our parabola is concave up. So it's got to be a negative number below the axis, the x-axis. So like right there. So there's the point negative 6, negative 2. And then, oh, I forgot all about our y-intercept. Well, I guess I could have changed the scale. Let's see if we can just kind of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, we're so close. 14, 15, 16. Sorry. We'll just do that on this one because we already finished graphing it. So we're 6. Now we're going to be 1, 2, 3, 4, 5, 6. This direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in an emergency case, sometimes you might just want to, like on our graph here, our graph's so big now. I'm trying to see our points. There we go. Making it reach to the sky. So we do have to graph our y-intercept. So a smart thing would have been to change the scale so that each point was 2. Kind of forgot that our y-intercept was going to go right off the graph. So when I said we didn't really need to change the scale, maybe it would have been good. But this is okay too. Right, but we still show it, our y-intercept, even though we had to extend the graph. If you haven't graphed it, and you were just kind of watching me and then you were going to graph it, you could just change the scale so it goes up by 2. So then each square would be worth 2. And so instead of the axis of symmetry being at 6 boxes over, it would only be 3 boxes over. And instead of negative 4, it would be at 2 boxes over. Instead of negative 8, 0, it would be at 4 boxes over. And that would be a good idea. Now, if you've already graphed it, you're good. Go ahead. Okay. Since nobody says, maybe I'm going to change the scale. So just if you haven't graphed it, I'm going to change the scale. If you have graphed it, it's fine. But what if you were waiting and you're like, oh, it's going to be right in the middle of my words. So we'll just change the scale. So this is 2. And this is 2 now. So this line here is still x, oh, it's still up there. It's still x equals negative 6 because every box is now 2. And so now this is going to be negative 4, 0. And over here, this is going to be negative 8, 0. And now I don't have to go off the graph because 1, 2, 4, 6, 8, 10, 12, 14, 16 right here. And then there would be a point over here. So this is the point 0, 16. And this is going to be the point, so I have to add 12, 12, 16. So if I'm 6 boxes to left, all right, and each box is 2, then I'm 12 boxes to the left. So negative 12, 16. And there we go. And now let's just connect our points. Oh, let's graph our vertex. So that would be right here. Now it would be negative 6, 2. Negative 6, negative 2. So if you haven't graphed it, now you can have it so it fits on the graph. So I probably should have just stopped and regraphed it. I decided to do it afterwards. And there we go. Oh, except for domain and range. Domain, of course, all real numbers. Range, so our low value is negative 2, the y-coordinate of the vertex, and it goes to infinity. 2 down. Let's see if we can get at least another one in and save the other ones for a part 2. All right, so we're going to graph g of x equals 4x squared plus 4x plus 1. Determine whether the graph opens upward or downward. So since a equals 4 is greater than 0, the graph opens upward. So we can say that it's concave up, or we can say opens upwards. Both are fine. Come on, letters. Sometimes I forget what the last letter I wrote was when I can't see it. All right, so axis of this one now is in standard form. Oh, I forgot to write on the last one, the format. And I said I was going to do that. So in your notes, if this one's in your notes, which I think maybe it is, this one was intercept form. And now we're moving along. And we already did that one twice. All right, so axis of symmetry, right? It's going to be also the x-coordinate of our vertex. All right, so we have x equals, oh, let's identify a and b. So a is 4, and b is 4. So that's going to give us negative 4 divided by 2 times 4. So that's going to be negative 4/8, which is negative 1/2. And so, like I had before, sometimes you maybe don't feel like plugging back in. So in this case, to find the vertex, another method for finding the y-coordinate of the vertex is the following formula. K is the y-coordinate of the vertex. Right? So we haven't graphed absolute value functions. We will in the future. And so H and K are the vertex for both of them. No new letters to learn. All right, so let's plug in our values. We have A, we have B. Let's just add C, and C is 1. So K, I'll put it over here, K is going to be negative 4 squared minus 4 times 4 times 1. All divided by 4 times 4. Right, so that's going to be negative, and so that would be 16 minus 16 divided by 16. Hey, did I write down something wrong? My shadow keeps blocking me. Did I put the wrong number somewhere? So 4 times 1. I don't see any errors. Right? So 4 squared, I would like to recheck my work. And so minus 4 is already there, times A, which is 4, times 1. Yeah, we got 16 minus 16 divided by 16. K is 0. So that means our vertex is negative 1/2, 0. Right, and I'll assume I'm right. I don't see any math errors. but if it's not 1/2 0, then we'll just double check later. And we'll know because our graph, all of our points, right, it has a very symmetric flow to it. So when we graph our points, it doesn't have that very nice symmetric flow, then we might have made an error. But I don't see anything. So let's find the y-intercept. That's easy, right? It's the value of c. And just to remind you, if you plugged in 0 for x, you'd have all zeros except for the 1. So our y-intercept is 0, 1. All right, so we have everything but our x-intercepts. And we're going to find that on the next page. So sometimes you might want to like, okay, factor that. And you don't want to take the time to factor, but factoring is the easiest method. So if you're not sure, go ahead and do the discriminant. So b squared minus 4ac, 16 minus 16 is 0. 0 is a perfect square. And if you remember, when the discriminant is 0, we have 1 repeated x-intercept when we have our discriminant is 0. So we have 1 repeated x-intercept, and it is real and rational, right, because 0 is a perfect square. So we can definitely factor, right? So our a is equal to 4, and our c is equal to 1. So 4 times 1 is 4. We need two numbers that multiply to give us 4, but add to give us our b term of 4. Well, 2 times 2 is 4, and 2 plus 2 is 4. So we have, and we're plus 2x plus 2x plus 1 equals 0. And the first two are a group, and the second two are a group. We'll factor out the greatest common factor, so we'll factor out a 2x. 4x squared divided by 2x is 2x. And then 2x divided by 2x, of course, is 1. And now we could factor out a 1 out of the 2x plus 1 because they don't have any common factors. So one of our factors is that repeating 2x plus 1, we could factor that out. We're literally just factoring it out. And if we factor out a 2x plus 1, oh, what happened to my 1? If we factor out a 2x plus 1, we'd have a 2x plus 1 left. So, and you don't have to solve this twice. 2x plus 1 is equal to 0. Right? Then we subtract 1 from both sides. So 2x is equal to negative 1. And if we divide by 2, x is negative 1/2. So our x-intercept is the point negative 1/2, 0. Well, where have we heard that before? Back here. All right, so if you have if your points here, we may have to plug in to graph, and that's the next thing we're going to do. Super quickly, like bunny, we're going to graph. Oops. Oh, I think I hit the page turn again. There we go. All right, so our axis of symmetry was x equals negative 1/2. Our vertex was negative 1/2, 0. Our x-intercept, or y-intercept, excuse me, 0, 1. Our x-intercept is negative 1/2, 0. And this is a repeated. We'll talk more about repeated, what that means, in a later lesson. However, for the quadratic function, it means it's going to be our vertex. So now, if we graph our points, oh, by the way, let's make our scale. Each box is equal to half, so that means that 2 boxes equals 1. That might be a little easier for us. Let's put our axis of symmetry in the right spot. So that means that negative 1/2, we just have to move it over one box. Come on. The good people that are watching would like me to finish. There we go. So we just had to move it over one box because each box is a half. Now, if we graph our points, all we've got is we have 0, 1, and so 0, 1 is up here. And we have negative 1/2, 0. Not a whole lot of points. We can use symmetry. We know there has to be a point here, right? And so that would be 1, 1, or negative 1, 1, excuse me. But maybe we want a little bit more than 3 points. So let's get one more point, and we're just going to plug in a 1. Right? So if we have g of 1, we'd have 4 times 1 squared plus 4 times 1 plus 1. And that's going to be, well, 4 times 1 squared is just 4 plus 4 plus 1. Oh, I hope it's going to fit on our graph. I guess I should have chosen a negative 1 because that wouldn't have been so far away. Yeah, that'll never fit on our graph because that's going to be 18 boxes. Let's just make it a negative 1. That'll be a much better choice. And, oh, we already have that point. It's going to be 1. Oh, we just can't win. All right. Let's try negative 2. And if that's too big, we're going with just 3 points. All right, so g of negative 2, 4 times negative 2 squared plus 4 times negative 2 plus 1. So that's going to be, I think this will be okay, Sam. All right, so that's going to be 4 times 4 minus, because that's going to be a negative, minus 8 plus 1. Well, this one fit. So, oh, 16 minus 8 plus 1, it's 9. All right, so there, with a scale of 1/2, I can't get any more points on it. So I guess we'll have to suck it up and just make each one worth 1. Otherwise, I can't get any more points on here. All right, so x equals 1/2 now is going to be over here. I prefer to change the scale. But alas, I can't get any more points on there. We only had 3 points. All right, so now this is negative 1/2, 0. It's okay. It'll be all right. So this now will be 0, 1. And negative 1/2, 0. And this one over here is going to be 1, 1, a negative 1, 1. So that's why I couldn't plug negative 1 in. It's like, big whoop, I already knew that point. So now we had 2 points, if you remember. So g of, I was trying to avoid plugging in a fraction. G of negative 2 was 9. And then g of 1 was also 9. So here's 2 more points for you. And I should have realized it because they're going to be the same distance away from our vertex. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then on the other side. And there's our graph. Super skinny little graph it is. And that, you know why it's so super skinny? Because our a value is 4. That's why it's so super skinny. There it is, but that's okay. Domain, course, all real numbers. And our range, our low value is 0. So 0 to infinity. And sorry, I don't usually like to make a 40-minute podcast, but now I'm done. Bye for now.